The root of completeness square, I'm going to say, let's go with this one. 4x squared minus 12x plus 16 equals 0. Okay. And I think you have to remember about when I tell you to solve the equation down in the following directions. You know, and a lot of people got into the equation here and said, solve the equation by completeness square, and a lot of people went to quadratic formula and just wrote the answer down. And give me a point. I just wrote down the answer. I wrote down the response. You had to complete the square. And I had to see the work. So like in here, if you remember the rules of completeness square, the first step is it has to have a 1 in front of my x squared term. So I'm going to take everything and divide by 4. Divide everything by 4. And so I have x squared minus 3x plus 4 is 0. Yeah, I don't know if this is going to work, but we'll do the work. We do the work of completeness square until it doesn't work. So the next step is what? No, that's not completeness square. So
Isn't that half of it?
half the middle term squared. Now, if we take half of it, we have to check it first. So in other words, we're going to take a half of 3, which is squared is 2.25. Is that the same as my last term? No. So therefore, I'm going to subtract 4. I have to get rid of this if it's not the same. And then I go back to that step again. And what I mean by go back to that step, now I have to put that number in there. So I say, well, half of 3 is 1.5. Squared is 2.25. So I'm going to say I'm going to add 2.25 here. I'm going to add 2.25 here. And so what I'm going to have, I'm going to do this in 2 steps. I have x squared minus 3x plus 2.25 equals a negative 1.75. Square. Now, if you remember how we did the one side here, on completing square, this side factors down nicely. This side factors down nicely. It always factors down to square root of that term, x, same sign, minus half my middle term, squared equals negative 1.75. Okay. Next thing, what we do? Square root of both sides. Now, if I take the square root of this side, and I take the square root of this side. This side, the square root and the square cancel off, so I'm going to get x minus 1.5. This side, I'm going to get, remember, we take the square root, you get plus and minus, but what happens?
There's no solution.
No solution. You can't take the square root of a negative number. Now I stop. I said, well, I can't take the square root of a negative number for now. Therefore, I stop right there and say, can't take a square root of a negative number. Negative number. So no solution. Now, if that wasn't a negative number, I'd keep going. I'd take the square root and keep going like that. If it wasn't a negative number. But this one's a negative number, so no solution. That's completeness square as you go. That help?
Yes. Okay, so then when you have something that has like, if it's 4x squared and then it's equal to, and there's no terms and it's just equal to another number, what do you do?
Well, there's a lot of ways you can do it. Let me take this out here. Let's say I have this one.
Like what equation would you use? Would you use complete the square?
6x squared, that means this thing equals 150. First of all, would I use completeness square? Probably not. The reason I say not, I shouldn't say not, probably not, I would not. You cannot use completeness square.
How do you know what equation to use?
Okay, and that's what I'm going to talk about here. Well, how do I know I'm not using completeness square? Because there's no middle term. Usually, if I solve down the equation, there's 2 ways. The first thing you usually do is try to get the number, everything on one side. I want it to equal to 0, right? So if I do that, I'm going to get 6x squared minus 150 equals 0. Okay. Now, how can I solve this? Could I use quadratic formula? Yeah, I could use quadratic formula. I know my a, which is, I know my b, which is 0, and I know my c, which is negative 150. I could use the quadratic formula, negative b plus or minus square root b squared, right? That's one way. One of the ways we did this problem where we did use that is we went through and said, okay, if there's no middle term, was solved by square roots. Not completely square, but square roots. What I mean is, I'm going to go back to this step here. Our ultimate goal of any problem is to get x by itself. So the first step here would be what? Divide by 6. And if I did the quadratic formula, I wanted to get the same answer. And then what would I do? Square root. So if I take the square root of both sides here, what am I going to get?
X equals plus or minus.
X is equal to plus and minus 5. Lots of people are missing the plus and minus. Lots. I would say 80% are missing the plus and minus. And that's a lot of points I'm missing right now, so that's kind of where I get that answer. Make sense? What else?
With the surface area last night, how do you compare surface area using equations? Like, I don't understand.
If you said the surface area, let's say, if I tell you the surface area of one figure is the same as the surface area of another figure, find the surface area of both figures instead of
Instead of what?
equal to each other.
Okay.
So, let me try to think of a good example here. Let's say this one. Let's say that's my figure. No clue how this is going to turn out. I'm making this up off the top. Find me the surface area of this figure. Find me the surface area. And what is surface area again?
All the surfaces added together.
Boiling.
All the surface
Length
area
times
that.
width, like times 6 if it was a cube. Right?
Yeah, if the length times width times 6 if it was a cube, correct.
So what is that?
This is, you would have to, it's not a cube, so what you're gonna have to do is you have to think about the 6 sides. Well, actually, these sides here, and the back and the bottom are all the same, right? So if I was doing the surface area of this figure, what I would have is x times x plus 2, right? And then I'm gonna take that answer times, there's 4 of those sides, right? One around. Because I got the front, top, back, and bottom. Now give me those 4 sides. Then I also have these 2 outside sides, which would be x plus 2 times x plus 2 times 2, because there's one on this side and one on this side. Correct? That makes sense? In the 4 sides going around the figure, those are the same, and then these 2, right? So I want you to multiply this out, FOIL through, FOIL 4 through, FOIL this, bring the 2 through, and add those 2 together. See what you get. If you don't have your card, you better come and talk to me because I'm not going to accept papers. It looks like a lot of people are getting papers in here. Okay, if you follow this out, the first one up here is, I'm just gonna go this way. I'm gonna get x squared plus 2x times 4, which is 4x squared plus 8x. Correct? And then the bottom one here, if I follow this out real quickly, I'm gonna get x squared plus 4x plus 4 times 2. And bring that through, I'm gonna get 2x squared plus 8x plus 8. Bring the 2 through. That makes sense? Hopefully. Now if I add those two together, it looks like I get 6x squared plus 16x plus 8. That's the surface area of that figure, right? Now if I said, okay, that has the same surface area as, I don't know what, let's say a cube with side 6. Same surface area with a cube with side 6. Okay, now a cube has all sides the same, right? So the surface area of that would be, area one side would be 6 times 6, which is
36.
times 6. So the surface area of this figure would be 36 times 6, which is 216, correct? So now when we set the equals as it has the same, what we're going to do equals 216. And the same area, surface area. Now how would I solve this? Well, a lot of different ways to solve this. First of all, I would get equal to 0. So I get 6x squared minus 208 equals 0. One of the things I might do to make the problem a little easier, since these are all even numbers, I might divide by 2.
Okay, for a prism, then do you just do like the 4 sides and those are all the same, right?
Usually.
That go around, and then you just do the 2 ends, and then you add them together,
If
right?
the sides are the same on the ends. In other words, I solved this out. Now, to finish up this one real quick, I would probably do the quadratic form. Okay, just solve this one. Now, if I gave you a prism like this, okay. Now, this side here is x plus 2 times x, right? The back side is the same, right?
Yeah.
But the bottom's not. The bottom is x plus 2 times x plus 3, and that would be the bottom and top. And then these two sides would be different too. So there could be more different sides. It might not be all these times 4. That's what I'm trying to say, because unless these two sides are the same, it's not going to be times 4. Does that make sense? Because that's an easy way to just change it, so you understand if you have surface area, not just memorizing the problem. Change that up a little bit. So. Okay. Questions on that?
Wait, so are we done with this thing?
I would do on this one, I would do the quadratic formula. If I was doing the quadratic form, I would have a negative 8 plus or minus the square root of b squared 64 minus 4 times 3 times a negative 104 divided by 2 times 3. Okay. From there, I have a negative 8 plus or minus 64 plus, I have no, 1248
Yeah.
over 6. So I get plus or minus the square root of 13 what? 1312 over 6. I might need a calculator to do the rest here. 36.22. So I have a negative 8 plus or minus 36.22 divided by 6. Right? So I got negative 8 plus 36.22 over 6, and I got negative 8 minus. So we can see what these two bring. Divided by 6. So this side would be 4.7033. I'd say rounded to the nearest tenth would be 4.7. Negative 8 minus 36.22 is a negative. Oh, I'm looking for a side length now. Which one makes sense? The 4.7. So if I went back to my figure up here, where my figure is here, my side here would be 4.7. This side would be 6.7, and this side would be 6.7. Correct? Does that make sense? Find the side line. And let's change it for a second. You want to get this down? Let's take the same problem. Doesn't take much of it. This is where I say apply it here. That rectangular prism has the same volume as a 6 by 6 by 6 cube. Same surface area, but volume. Find my axis. Same volume. How do you find volume of a 6 by 6 by 6 cube? Or how do you find volume of a rectangular prism?
Length times width times height.
Okay, do it. Length times width times height. So if I was working this out, my volume would be 6x squared plus 12x, correct? Now it has the same volume as a 6 by 6 by 6 cube. So what is the volume of a 6 by 6 by 6 cube? Is it
260.
216? 6 times 6 is 36 times 6 is 216. Length times width times height. So this has the same volume as a cube, and it's 216. Now if I subtract 216 off both sides, then what can I do? I think everything goes into 6, doesn't it? So I'm going to get x squared plus 2x minus 36. What is it? Don't think it factors. So if it doesn't factor, what do I have to use? Quadratic formula. So use the quadratic formula. two answers here. We got 10.17 divided by 2, 5.085. This is going to be a negative 7.085. Which one makes sense? 5.085. That's going to be your closest answer. For negative, you can't have a negative side, right? Now, if I went back 5.085, and went back to the original problem. Here's my problem. This side says x plus 2, so what would it be? 7.085. This side says x, which is 5.085, and this side says 6. Correct? If I multiply that together, what should I get? 216. Let's multiply again. 7.085 times 5.085 times 6. I get 216.163. Why? Around. If I round my values, I mean, I didn't use the exact values, did I? If I wanted to use my exact values in the bottom quadratic formula, I would have got 216. I rounded, so therefore I didn't get the values exactly, but I got close enough. Does that make sense? Now, do you see what I mean? I know some people have asked me this online. It says, I haven't seen a problem like this. Have you ever seen a problem like volume before? Not volume. We did all surface area, right? Is it any different than solving down a surface area problem? This is what I mean by knowing your concept, not knowing a problem. I want you to be able to apply this stuff. If I give you a problem that says volume on it, and you haven't seen it before, now I can do the same thing here. Now, what could I do in the problems test? I could say, the volume of, I probably wouldn't do this because it's a hard formula, but I could say, the volume of a sphere is this, and the volume of this sphere has a radius of x. What is the, what is x, you know? I could put volume of a sphere, I could, I'm not going to. Most people do not know the volume of a sphere. But it doesn't mean every problem you're going to get on a test is going to be exactly what we did in class. You need to learn how to apply these concepts, understand what they mean. Does that make sense? Not just, okay, everything we do in here is not going to be exactly what you're going to see on the state test or anything like that. Like I said, the other class, next year is the state test, and I don't think there's any ways around it as of now. You have to pass it to graduate. That's the new rule. You guys get to be the privilege. So it's not 3 times and you're done. So. Any other questions? I kind of covered that one. I kind of beat that one pretty bad. Anything else you have to that you don't remember? Nothing. We're going to teach this test tomorrow. We'll do the I didn't forget it.
When you use a discriminant.
A lot of people use a discriminant when they, most of it when I ask you to, but sometimes on the quadratic formula I would use a discriminant too. A discriminant doesn't tell you a lot. The discriminant tells me, what you call it, how many solutions I have, okay? If I started a problem with, if I'm going to do, I know I'm going to do the quadratic formula, let's say. Like on this one, I knew I was going to do the quadratic formula, right? I might do the discriminant right away to see if my discriminant is positive, negative, or 0. Okay. One of the rules you don't really, you know 3 cases. What's the cases? If b squared minus 4ac is greater than 0, what do we know? 2 real answers, right? So I would work the problem up, correct? If b squared minus 4AC is less than 0, no answers. I can stop. I don't have to do the problem. No solution for now. Correct? What happens if b squared minus 4AC is equal to 0? One solution. What is that solution? Not 0. The one solution is always that. That's going to be your solution. Whenever you get it equal to 0, the only solution to the problem is a negative b over 2a. No, I should say that, but whatever b is, 2a is the problem, right? So for example, if I did this problem, okay, and I did the discriminant, b squared, what's b? Negative 4 squared minus 4 times 1 times 4, right? Which is equal to 16 minus 16, which is 0, right? Discriminant is 0. How many solutions? 1, right? My only solution to this problem is going to be a negative b over 2a, which is or over 2, which is 2. X equals 2 is the only solution to that problem. X equals 2 is the only solution. One of the rules, little tricks that they don't explain too often, but that is the only solution. How do we know that? Any clue? How do we know that? What's the quadratic formula? How many remember the quadratic formula?
Negative b plus or minus square root b squared
Over. Okay. Okay, what did we just say with the discriminant equal to 0? B squared minus 4AC equals 0, correct? So look, go ahead.
It's just what's left.
Yeah. This is 0, right? Square root of 0 is 0, so really this is gone when b squared minus 4AC is 0. What's left? Negative b over 2a. That's your answer. So really, you do the quadratic formula, but you don't have to do the whole thing. It's just what negative b over 2a is. What else does negative b over 2a tell us? The vertex. What question for you? When do I want to find the vertex? When I find the maximum or minimum? I usually do not use the vertex formula to solve anything. In other words, if I say solve this equation down, I'm not asking for the max or min. If I say solve the equation down for the max or min, then I use the vertex. And there's some problems that I've seen on some of the homework class or weekly quizzes. It says solve the equation, and people are doing negative b over 2a. It's like, solve these, tee it up, factor it, quadratic formula. I don't do the vertex formula unless it's asking for a max or a min. Unless it's asking for a max or a min. Question on that.
So like on the discriminant, if there is 2 solutions, are we gonna have to figure those out? How do you do that?
Just finish the quadratic formula. That's all I would do. Let's say, for example, I did this one. Minus, it's a minus. Okay, that's our problem. Now, if I did the discriminant, b squared minus 4ac, what's b?
-5
Negative 5,
minus 4 times 1
negative 8, right? So you got 25, 2 negatives make up,
times
plus 32, right? Which is 57. Everybody agree with that? 57 is greater than 0, which means it has 2 solutions. Now, I something I can find. Negative b plus or minus. Right? What's b again? Negative 5, right? Now, do I have to do this whole thing over? It's equal to 57. So you might want to do it over just to check the work, but I already know that's 57. Over 2 times 1, and just simplify that down. I can give you a little hint. One little hint here is this. If you do the discriminant, I don't know if you remember this, I thought it said in the video. If I do the discriminant and it has a perfect square root, what do I mean by perfect square root?
Like square root of 49
If
is
it's like
7.
60.
49, 64, 36, anything like that, okay? Then you can tee it up. So, if that number is a perfect square root, the problem is vector. That's not written anywhere. Right? If that number has a square root of your discriminant, so like 36, 49, 81, whatever, then you could tee up your problem and not use the quadratic formula. In other words, you're going to come up with a nice answer. Okay? So,
Quadratic formula always works, right?
quadratic formula will always work, yes. I guess the reason I say that, I know this is the part here where people say, well, why don't I use the quadratic formula all the time, right? You know, why do I have to know that? And it comes down to this. What kind of equations are we using? Quadratic. And Ariel knows this right now, we're doing it in another class. Is quadratic the only ones we're using? We're going to go to x to the third, x to the fourth, x to the fifth, x to the sixth, x to the seventh, and keep on going. Maybe we did x to the 10th this year. Up to the x to the 10th. And factoring works on those. Okay? But the quadratic only works on quadratics. Okay? Follow me? You can only use the quadratic equation if you have x squared. Where factoring works all of them. If you do that. Does that make sense? That's why we need to know both. We can't just know the quadratics and we're going to use it all the time. Because when you get to the other ones, it's going to be too hard. Much on that. We got 7 minutes left. 20, 9 minutes left. What else?
Was there any question like there was on the last day?
Okay. I like this one. I really do. I change it up quite a bit as it goes through. Again, this is kind of applying the concept here. I think it said something like this. Okay, 50 feet of fencing. And the area was, I believe, 150. Is that right?
The W and L
W and L, it doesn't really matter, but we'll do it that way. W and L, okay? And the answer to this is not impossible. Really tried it, but it's not impossible. Actually, I like doing this. We've done these a lot, actually. This is a house or whatever here. What does the 50 feet represent? The length of the fence all the way around, right? The 3 sides, right? If I have my 3 sides here, what I know is this side's W, this side's W, this side's L, correct? Agree with me? Would you agree with me for this if I wrote down 2W plus L equals 50? Would that make sense? The two sides, this side and one long side equals the whole fencing? That makes sense? Now, when we solve a problem down, one thing you have to realize, we can't solve a problem down with 2 variables. Correct? Right now we have 2 variables there. One other thing we know is the area. How do you find area of this rectangle? Length times width. If I did this one here, length times width, I'm going to have W times L equals my area, which is 150. So I have 2 equations. And again, both equations have 2 variables, correct? Problem is we have to take one of the equations and get it down to one variable. So probably the easiest way to do that is, can I solve for L on this equation? What can I do? Okay, subtract 2W from both sides, and I'm going to get L is equal to 50 minus 2W, correct? Do I know what L is? Yeah, 50 minus 2W, right? So what I'm going to do now is go down to this equation, and wherever I see an L, I'm going to put in 50 minus 2W. So what I'm going to have is W times equals 150. Okay? Now from there, Bring that to the parentheses, I'm gonna get 50W minus 2W squared equals 150. Right? How do I solve this? I have to get W by itself, but I got it squared in the middle term, but I have to get 0 on one side, correct? So I'm gonna move everything over to one side. Now, there's a couple ways to do it. I'm gonna add 2W squared here to both sides. I'm gonna subtract 50W from both sides. So what I get is 0. Can I do anything to help this problem? Divide by 2. There also divide by 2. I'm gonna write it out. If I divide by 2, I'm gonna get this. Divide by 2. Right? How do I solve from there? I don't know the factors. So I had to do the quadratic one. And negative b, the negative 25, plus or minus negative 25 squared minus 4 times a times c over 2a. Two negatives make up? Get 25 plus or minus, I think that's 625, minus 300. Divide by 2. And do you see where we'll go from here? I think you can see the direction you go. Get two answers. One's going to be positive, one's going to be negative. You want to accept the positive answer. Does that make sense? Oh, L is pretty. Once you find W, this is your W answer, right? You can go right back to here is L is equal to 50 minus 2W. Right? Put your W in and get to the side. Questions on that? Any questions on that? Okay. I got a question for you. You got 4 minutes left. This is for extra credit to add to last week's weekly quiz. If you want. Don't. You have to post it to me though. You have to post it, the answer. And you have to tell, I thought about it, wherever else it's gone today. Okay? Yeah, 50 feet of fencing. Okay? 150 feet area. You're fencing in the backyard. Here's your house. The fence goes like this. This is your house right here. So we have a, let's put W here. We have W, we have L, we have L, we have a half W. That's your fencing. You have 50 feet of fencing, you get 150 feet there. Figure out what W and L is. Not much different. A little bit. Set up the same way. Set up the same way. As you can see, it doesn't take much to change a problem. I put a third W in there. I can do a lot of different things, but this doesn't take much to change a problem. Same numbers and everything, right? So I want you to see what you can come up with there. You can pull it that there, put it on your test. Think about what we did. How do we figure out the fencing? How do we figure out area? Area's not going to be hard. Area's like that. Okay, everybody put your calculators back. This bell's gonna ring in a minute. I want to see what's missing here. I have to see what's missing.